F is a periodic function. One period of the graph F is shown below. On the interval -10 to 10, and including those numbers, how many values of x satisfy the equation f of x equals 1? Well, here's issue number 1 and issue number 2. Issue number 1 is I only give you 3 spaces of this thing that's supposed to stretch out between -10 and 10. Issue number 2 is I don't have -10 to 10. So this is how I'm going to handle this. I know that this repeats its behavior every 1, 2, 3 spaces. So what's going to happen is f of x equals 1 exists here and here. And all of these repeat every 3 spaces. So where are we right now? We're at 3 right now for that one. So let's do different colors. Let's ignore the fact that I drew that there. Okay, let's bring back the blue. And so what's going to happen is I'm going to hit this spot every 3 spaces. So 3 plus 3 at 6, this is going to happen again. At 9, that's going to happen again. Now at 12, it's going to happen again, but I don't care. Let's go in reverse. At 0, it's going to happen again. At -3, it's going to happen again. At -6, it's going to happen again. At -9, it's going to happen again. At -12, it's going to happen again, but I don't care about -12. Okay, so also we are at 1, 2, 3, 4, 4.5 right there at the green spot. So f of x is equal to 1 at around 4.5, which means at 7.5 it'll happen again, which means at 10.5 it will happen again, but I don't care about 10.5. Let's get rid of that comma to keep consistent. Now let's go backwards. At 1.5 it'll happen again. -3 is going to be -1.5, it'll happen again. -4.5, it'll happen again. -7.5, it'll happen again. -10.5, it'll happen again. But that's all that we care about because we're not going beyond -10. So we have 1, 2, 3, 4, 5, 6, 7 instances where this part hits 1, and we have 1, 2, 3, 4, 5, 6 instances where this part hits 1. 7 plus 6 is lucky 13. So kind of a bizarre, unique problem, but the purpose is to demonstrate how periodic functions repeat, and it just makes you think outside the box a little bit.